Hello everyone, good morning. A warm welcome to you all for joining in for today's session on network. We'll start at 10:05. So we'll wait for 5 more minutes for more people to join in. I humbly request you to wait for 5 more minutes. Then we'll get started. So, hi, hello everyone. Thank you for hopping in this Sunday morning to join our event. So, before going into the event, I just have to introduce few things which we are doing in from AWS User Group Madurai point of view. So, the first one is like AWS Student Community Day South TN. So, this event is happening on October 25th in PSNE College of Engineering and Technology, Dindikal. So, this event is a collaboration of two AWS Cloud Clubs with AWS User Group Madurai. So we are doing this for the first time in South India. So people who are near South India who wish to travel for the Student Community Day are feel please feel free to register and attend this event. So the general ticket sales are open and there is a very short tickets limited. So please uh, try and get your tickets as fast as you can. Next one, as you know, builder skill sprint, we have successfully done 4 skill sprints in the last 4 months with 4 different teams from Gen AI, serverless, DevOps, and networking this month. So we have announced winners for all the previous hands-on challenge winners, and we'll be facilitating them in this Student Community Day South India TN. So I welcome you for this networking session builder skill sprint. So today we'll be having Adit as a first speaker. So hi Adit. So welcome. So as many of you know, Adit is a community person. He's a solutions architect at Lauren. He's also a AWS community builder and AWS ambassador. And on top of that, he's also a golden jacket holder. Like he already like he completed all the AWS certifications. So I think he's a very right person for us to explain the networking basics and to get us started on. So welcome, Adit. Uh,
Thanks,
I'll stop.
yeah. Thank you, Pubalan, and thanks to AWS User Group, Madurai, Vivek, you, and Lokesh for conducting this monthly skill builder thing, which is like each theme is different. Each month you get to learn about new things, and hopefully it excites people to learn about AWS and learn about different concepts within AWS, right? I'm excited to talk about this in my session today. Perfect. Um, I can share my screen and get started, right?
Yes, please go.
Okay, cool. I'll just set a timer so that I know that I don't need to exceed that timer. And then I can just share my screen. Let me know the screen is visible. You can see the screen, right?
Yes, your screen is visible, and I have added it to stage. So I'm removing myself.
Okay, perfect, perfect. Cool. So, hi everyone. As Bhubalan introduced me, I'm Adit Moti. I'm a solution architect at Lauren, and I'm also an AWS community builder and part of the AWS User Group Vadodara. Golden Jacket holder. I've got all the AWS certifications, 12x AWS certified, and I try and get more of them. So I'm renewing my DevOps and Solution Architect Pro. So if you are in the similar journey, do reach out or connect with me. Happy to help people as well as learn more from people, right? So that's about me. So for today's session, I'm going to be covering a topic called mastering AWS networking from VPCs to global connectivity, a holistic approach. So the idea behind this session is, as you know, this is the networking theme for this particular month, and my goal with this session is to give everyone a holistic view of the different components that form the AWS networking. So within the networking space in AWS, there are different components, right? And I want to cover all of them from a holistic perspective, from a high level perspective, to give the listeners a read of what are the different components, how are they being used, and how can they start working with these components. And it is again going to be very beginner friendly, beginner to intermediate friendly. So people who are beginners or starting out, or maybe someone who's started using AWS for maybe 1 year, 2 years, can get value out of it. So that is going to be the focus for this session. And after my session, we'll also have someone else joining who will talk about another topic, which is going to be a more advanced topic, right? So that is going to be the goal for this uh, session or this month's theme. So without further ado, I'll just go forward. So the agenda for the session is going to be introducing networking and just talking about why networking matters, right? Why would anyone want to understand networking from a overall perspective? How important networking is? So we're going to be discussing that. Then I've divided the network AWS networking space into four layers, right? So cloud networking foundations. So what are the foundations within networking? Your VPCs, your subnets, your internet gateway, net gateway, or security groups, NACL. So we'll discuss those. And then that is going to be the foundation for any of your architecture that you design or any of the networking that exists. That is the first point of discussion. Then we'll move forward to layer two, which is multi VPC design. So it takes the foundations of level up, which is how do you connect a VPC which is designed, which is the foundation, to another VPC, right? So you're trying to enhance or make your architecture more robust or more scalable in that sense. That is the second layer. The third layer is more around how do you add the securities, the observabilities into this design, right? Because the first layer is foundation, second layer is making it scalable, but then the third layer is enhancing it with security and observability. So that is going to be the third layer. The fourth layer is more about advanced connectivity patterns, right? So yeah, foundations is good, scalability is good, security and observability is good, but there are a couple of times that you might face scenarios where you need connectivity or need to understand more patterns and make it into something which is complicated, right? Maybe it is more advanced than you normally are aware about, right? So there are different concepts which fall into this advanced connectivity patterns. We'll discuss some of those, and then finally we'll do a live architecture dissection. So uh, there is a complex architecture that I'll show you in the beginning, and then at the end of the session I hope that you are able to understand most of the components within this uh, hard or difficult architecture, and then we can dissect few of those components. Finally we'll wrap up and takeaway will be there. So in that particular thing, I'm hoping that I'll share you one or two components that I think you should be taking away from this session, if not entirely everything, but just take away one or two things which will help you when you design or build out your architecture from the scratch. And then I'll also share you the challenge that you should be taking as part of this sprint month. So yeah, without further ado, let's start. So yeah, intro, why networking still matters, right? So whenever we design an architecture, networking is very important to that architecture. I'll tell you how, right? So what comes to your mind when you think about AWS, right? You most of the times think about your S3s, your Lambdas, your SageMakers, your EC2s, your DynamoDBs, right? So those are the normal services that come to mind when you think about AWS, right? But what if I tell you that everything that you have talked about is powered by networking, right? So networking forms the foundation or the basic behind all of these AWS services that you are talking about, right? So networking is really important, right? But then when you try and work with the AWS networking services, you might become puzzled, or it might become difficult for you to understand how these AWS networking services or components are interlinked with each other or combine and form something which is like this complex, right? So you see an architecture as of now, right? How complicated is this architecture? It has multiple components, it has multiple services that are being used, right? Each of them is very complicated in the sense that I don't know how each of them get is interlinked to form this entire architecture, right? So that is going to be the focus of this session. I hope by the end of this session, we are all of us are aware about the different components that form this particular architecture. That is going to be my goal in this particular session. Okay, so when we try and build out AWS architecture or maybe a solution, right? So we are trying to build out a solution which is maybe a server on an EC2 instance, a database in RDS, right? So this is a very simple architecture that I'm trying to build, right? But then everything works fine for a couple of days, but then when I try and uh, see, there are a couple of errors that I'm facing, right? So maybe I'm getting that failed to connect to MySQL, right? Some API timeout happens. Maybe there is something like 503 errors, right? Maybe something like uh, we're getting cannot connect to DB, right? So all of these errors, when we try and first debug, we think that, oh, this error might be because of XYZ reasons, right? Maybe because I've not written my code properly, I've not made my connections properly, right? But then when we try and dig a bit deeper, it's actually because of the connections that have been set up in within the networking layer itself, right? So maybe a route table is not properly set up, or maybe the peering that you have done is not proper, right? So again, this is a very common scenario when we try and build a system, the system's working for a particular duration and then suddenly it stops working, right? So this is generally it is due to this particular issues that the system might not work, but that is again something that we have to understand what why is it being caused, and how do we remediate from this type of errors, right? So again, this is just as an example. When I first try and encounter these errors, we already have something called CloudWatch setup, which is going to tell us that there is a threshold, there is something which is causing an issue. So you get an alarm, you get to understand, okay, something is not working. Then you maybe go into the logs and see what is not working, how it is not working. Then try and understand, okay, is it application error, is it a networking error, what error exactly it is, right? So that is how you try and debug. But this is again just to give you a glimpse of in sometimes it happens that it is an application error, but more or less it might also be a networking error, right? So that is how you have to understand things, right? So when we this is a very important question, right? Which is when you try and design an architecture, a networking architecture specifically, right? Are you designing the architecture to scale, or is it just waiting to fail, right? So this is important, right? Because whenever we try and design an architecture, we need to uh, learn or maybe understand about the different components that form this architecture, right? It could be components of maybe uh, making the foundations better, maybe designing it to if there is a failure, how do we mitigate that, or if security is considered, observability is considered, right? So when we say, are you planning for growth, right? It essentially means that are you planning to ensure that the architecture that you have designed now can scale or can be uh, remain the similar architecture when you're trying to grow this architecture, right? So maybe sometimes what happens is I've designed a slider in a 10.0.0.16, right? So which has very less IPs compared to 10.0.0./24, right? Which has more IPs. So when I design an architecture, am I thinking about growth or not, right? So if I've designed it with a lesser IPs and then probably the VPC or the architecture grows to a certain limit, right? Then I'll have to again make changes to it, which again causes it to fail some more times than less, right? So this is something that we have to work on during the initial phase itself, right? We have to try and ensure that the architecture that we build is designed to grow and is scalable from the beginning, right? Second is, have you isolated the blast radius, right? Now this is a very interesting question, right? Because whenever you design an architecture, you also need to, or a networking architecture specifically, you also need to understand that in many of the cases, it might so happen that there might be some issue that might cause some of the architecture to fail, right? But the issue shouldn't cause the entire architecture to fail, right? So that is how you have to limit the blast radius. I have to ensure that how I can isolate it, how I can make it only limited to particular components and not every component, right? That is something that you have to look at, right? So maybe something like making components private, making components public, and then only ensuring that the private components remain private and that those components are within that particular VPCs. So all of this will ensure that you limiting the blast radius, right? If you're not thinking about these things during the initial building of a networking architecture, then or building the or designing the architecture, then you'll probably have missed these components. And when you uh, are looking at a situation when you've scaled the architecture to thousands of users, then these issues try and creep up, and then you don't have any solution to this problem. You have to redesign the architecture, right? The third component is, can you debug networking failures easily, right? So I was showing you the earlier section where I said the day nothing worked, right? So that is probably a very common example, right? So if there are things that are not working, how do I debug from them? How do I understand that, hey, this is not working, or this is working not properly as expected, right? So all of this can be done with that observability piece that you're talking about, right? So that is also again very important to set up from the beginning, so that later on you don't get to face this debugging issues, correct? So As I said, I will go over the foundations, VPC, subnet routing, multi VPCs, transit gateways, peering, security, and then global connectivity. Right? So yes, to begin off, cloud networking foundations, right? So foundations are very important when you design any architecture, right? It forms the basis of all of your architecture choices, decisions that you have made. So if you look at it, everything starts with a VPC, right? So here in this architecture diagram, you see a VPC, right? But within the VPC, you also see different components, right? You see an availability zone one, availability zone two, then you see public subnet, and then there's a NAT gateway, ALB, private subnet, auto scaling group, security group, right? And then there is an S3 gateway, right? And then there's an internet gateway, right? So there's a lot of components here, right? So let's try and dissect these components into pieces, right? So first thing is a VPC is basically like a foundation. So consider it to be something where all of your AWS services reside. So anything from servers to databases to other components, all of them reside within your VPC. So it is like a foundation or the basics of your architecture. Then some okay, this is then I wanted to also mention that if you don't design a VPC properly, meaning when you create a VPC, you create a VPC, but you also create subnets, you also create route tables. So it is very important to design the VPC properly. Proper side end needs to be assigned, proper configuration need to be done. Because if you don't do that, then there is maybe you have misconfigured a route table, and that might lead to some issues, right? So it's just an example of a route table that is there, private and public route table. And then if there is a cider misconfigured in the route table, this may lead to your application not even being accessible to the internet or not even being accessible to you, right? So you need to avoid misconfiguring things, right? Okay, now let's dive into internet gateway versus net gateway. So the idea here is you use internet gateway to connect to the internet, correct? So any connections from a public or private subnet goes via the internet gateway to the internet. Whereas with NAT gateway, the idea is NAT gateway resides in your public subnet. So any connection or anything from the private subnet goes to the NAT gateway, and from NAT gateway it goes to the internet. So this is just an architectural view. But if you look at the feature comparison, it is more or less internet gateway allows both inbound and outbound, and net gateway only allows outbound internet from the private subnet. So any request that comes from private subnet is the outbound goes from the net gateway to the outside internet, right? Whereas in internet gateway, it is bi-directional, right? So it's a inbound connection and then there's a outbound connection, correct? And then internet gateway is something which is used with public subnets. So public subnets will have an internet gateway, whereas net gateway is something which is used with private subnets, right? Then inbound connection, yes. So this internet gateway has direct public IPv connections, whereas net gateway cannot accept any inbound traffic, right? And the use case for internet gateway is mostly public facing web servers. Any public facing web servers like an EC2 or a server is basically routed via the internet gateway. So any request from the internet goes to the internet gateway, and then internet gateway routes it to the public facing web servers, right? And net gateway on the other hand is something which is in the private subnet. So basically it is going to be used when I want to maybe make patch request or update request to that private subnet, and then the request goes via the net gateway to the internet gateway and to the outside website. Security, it requires careful. So your internet gateway, you need to be very careful in the sense what connections are coming in and going out, whereas private resources within the net gateway stay unaddressable, right? So I'll just go and show you this, right? So this is, if you look at the diagram, this is the NAT gateway, which is in the public subnet, but then all of the resources in the private subnet go via the NAT gateway to the internet. And the internet gateway is something which is in the, you see the internet gateway is here, and any request that comes from the internet goes via the internet gateway into the VPC, right? And this is the NAT gateway. Any request from the private subnet goes to the NAT gateway and then internet gateway and then outside, right? So that is going to be the structural difference between both of them. Okay. The next component that I wanted to discuss was a public subnet versus a private subnet. So again, the main difference of public subnet and private subnet is public subnet has access to the internet, private subnet doesn't have access to the internet, right? That is the major difference. But if you look at the more differences, internet access is direct access by internet gateway, no direct internet access. That's what I was talking about. This is another difference, which is like what are the use cases where public internet makes sense and a private internet. So your web servers, your load balancers, your caching hosts, all of them are in the public subnet. So here you see your ALB is here, maybe your passion host is here, right? So all of them in the public subnets. Whereas your app servers, databases, internal services all reside in the private subnet because they don't need to have an access to the internet gateway, right? So that is the core idea. Then points to the internet gateway. I was talking that the public subnet points to the internet gateway, and then points to the net gateway or no ICW. So private subnet points to the net gateway. Correct? That is the flow. Exposed to internet and isolated from the direct external internet access, right? Then you need strong security groups because you need to protect it from the internet. So you need to have strong security groups here, and this is protected by net and security layers also. Correct. So yeah, so we discussed on a couple of components. Now I think the next piece will be the security groups versus the NACLs. So if you look at this diagram, each of your servers will have a security group and an NACL on top of it, right? So yeah, so the basic difference between security group and NACL is security group is stateful, NACL is stateless, right? So whenever a request comes from one inbound is there from any internet to your resource, the outbound is automatically allowed, right? Whereas in NACL you need to allow both inbound and outbound. So that is the meaning of stateful versus stateless. One request is there, the other request is automatically allowed, right? Whereas in NACL the inbound is also checked, the outbound is also checked, right? uh, the security group is at the instance level, which means that any EC2 instance will have a security group, right? Whereas an NACL is at the subnet level. So it might happen that one EC2 has one security group. There are five EC2s and there are five security groups. And all of these five security groups or five EC2 instances in five security groups have one subnet on top of it, which is why the which will have one NACL on top of it, right? So NACL is at a higher level compared to the security group. Correct. The directional rules is inbound and outbound and separate for in and out, right? So which means that if you allow an inbound to happen, then outbound automatically happens, which is what I was talking about. Whereas here in NACL, if there is an inbound, it will have its own permissions. Whenever a request goes out from the resource to the internet, it will have its own rules or permissions, right? So each request, whether it's an inbound or an outbound, is monitored. Whereas here, if it is once an inbound comes, it is automatically going to go out because there is no outbound permission that are set, right? The inbound and outbound are the same, correct? The use case here is fine-grained access control. So you want to have fine-graining access for your EC2 instances, then you will use something like a security group. For NACLs, the idea is you want to do a subnet level restriction. So I might want to have a NACL policy saying that I will allow only this particular rules to go through, right? So maybe I'll say I don't want HTTPS to be allowed, or maybe I'll say I don't want a particular port, right, port 22 or port something else to be allowed for all the EC2 instances in the subnets. That is something that I can deny via the NACL, right? Whereas security groups is something that I will restrict or fine grain specific to my EC2 instances, right? So that is how I try and typically use both of them, security groups versus Snacker, right? Okay. So this is like a journey of a user. So user client makes an HTTPS request. It goes to security group, and then it allows inbound request, and then it goes to an EC2, and then from so here on top of the security group there is an NACL also. So NACL is also allowed inbound to happen. That's why it is going inbound. Security group has also gone inbound, and then EC2 it has reached, right? Now after EC2 it has reached, the security group will also allow outbound because for security group both inbound and outbound are allowed. But when it goes to network access layer, NACL has denied an outbound request. So what happens? It is denied. Here it is important to understand that even though the security group had allow inbound and outbound on the 443 port. Because the NACL had denied the outbound, it got denied, right? So that is how NACL is able to deny request. And here it is important to understand that this is probably one of the important reasons of using NACLs. When you want to deny something uh, across your EC2 instances, multiple instances or other things within your subnet, right? Maybe it is database also, right? So you can deny it everything on the subnet level, right? Okay, so I think I'll move on to the next bit, which is gateway endpoint versus interface endpoint. So gateway endpoint, the idea is uh, you use it for private access to S3 and DynamoDB. So consider a use case that you have your EC2 instances or virtual machines that you want to connect to S3 or connect to DynamoDB, right? One way to look at it is they go via the internet gateway and outside internet and then try and access S3. That is one option, right? But there should be another way that these EC2 instances or virtual machines connect to an S3 or a DynamoDB, right? So that is the gateway endpoint. That is the layer that allows them to connect via that option. And then the interface endpoint is probably another endpoint approach to connect to give a private access to other AWS services apart from S3 and DynamoDB. So, for example, if my EC2 instance needs to connect to something like an ECR, right? So it's a Elastic Container Registry. So that can happen if I've set up a interface endpoint between this EC2 instance or this virtual machine to the particular AWS service, right? So that is the major difference. This gateway endpoint is for two services. This is for most of the other services. Both of them give you the private access to the services. Gateway endpoint again is free, whereas the interface endpoint is charged per hour per GB. So it is charged for every hour that is being used and for the per GB that it just transacted, right? Then the other things to look at is it is route table target to. So here you have to connectivity happens via the route table, and here it happens via the ENI in the subnet, correct? And then underlying how it is configured is via route table. Here it is using private link. Supports only two AWS services, supports other services as well, and then endpoint policies, right? So yeah, that is more or less the difference in terms of an architecture. If you want to look at it, this is how it looks, right? So your VPC has your gateway VPC endpoint, and then this is an interface VPC endpoint, right? So gateway VPC endpoint, if any AWS service is there, maybe it is EC2 via the gateway endpoint can connect to S3 or DynamoDB. But in case of your interface endpoint, they connect via the ENIs and to that particular AWS services. So these are the list of services that they want to connect to or may need to connect to. ECR is also one of them that I was talking about. Okay. Okay. So I will want to just go and show you a VPC. How do you create a normal VPC? That is something I want to demo. But before that, any questions so far? Uh, if there are any questions so far, Kubalan, please feel free to let me know so I can answer those.
Hello, Adit. As of now, I don't
Yeah,
see anything. Can we take it at the end of your session?
sure. We'll take all of the questions at the end of the session. No worries. Cool. So I'll create a VPC demo. I am in my AWS console. I just need to write VPC, and then you can see VPC is here. I am in the US East one. You could also change it to Mumbai. That is all up to you. If you just click on your VPCs, you will see this is a default VPC that is already created for you, right? Uh, Now what I'll do is I'll create a VPC, correct? So when I try and create a VPC, I see that there is VPC only here, and then there are VPC and more, right? So you see there are a lot of different components that you can see here. One is a VPC, then there is subnets, and then there are route tables, and then there is internet gateway, and then VPC S3 endpoint, right? So all of these components can be created. So uh, depending on what your need is, right? So if I just want to create a VPC, then I will just create a VPC with some name, and then it will maybe my VPC, and then IPv slider, and then I'll give a slider range, and then it will create for me. Correct. I want to create a VPC more, right? So I'll say, okay, name auto. So this is again going to be auto tagging it, right? So that is again something that I've enabled. Here I can select a slider block, right? So you see, when I select a slider block, it gives me the IPs that are available, right? I can maybe say 24, so it's only this much IPs that are going to be available, right? So it depends on what your need is. For now, I'll just put on the simple 10.0.0.16, and then I don't want any IPv6 slider blocks here. The tendency is default versus dedicated, and then you have options, right? You can have two AZs, you can have three AZs. I just want to keep it simple. I'll have two AZs. How many public subnets you need? I may say, okay, I need two public subnets and two private subnets, right? The default one. Uh, okay. So then NAND gateways, I'll say I'll need one in one AZ or one per AZ or none, right? There is the option I can go with, right? So I'll say one AZ per AZ, and then VPC endpoints, right? So this is the thing that I was talking about, right? You can connect it to IS3. I can say I don't want it, or I can say I want it, right? And then you can see preview code also, right? So preview code basically means console to code, right? So it just basically tells you, right, what are the commands that are being run to create these resources for you, right? So you can see a list of those, and you can download it also, and you can also generate an IAC component for all of them, right? That is also possible. I just create VPC. All of these resources are going to get created for me. VPC is created, DNS is created, VPC S3 subnets, NAT gateway, right? All of them are getting created for me. Correct. So these are very basic setup which creates all of the resources for me. Right? I'll just move on. I have the second demo which will interlink to this. So I'll show you how it will work. But basically, this will take some time. So let's just wait for that to be created, and then I'll move on to the next bit. Right. Okay. So the second component here is the scalable multi-VPC design, right? So here, uh, first we have to try and understand why there is a need of having a multi-VPC, right? So the motivation behind a multi-VPC, right? So sometimes what it might happen that you have scaled beyond a single VPC. So you have scaled your application in such a way that you cannot uh, continue using a single VPC because of isolation, because of security, because of resource quotas, right? It might happen that you have now moved on to multiple teams, right? So there are different ABC 3 or 4 teams. Each of them need their own security setup. Each of them need their own isolation, and you're also running into this resource quota limits, right? With a single VPC, maybe they're limiting you to the number of nights you can use. They're limiting you to number of IPVs you can use. So all of this start to creep up when your design or your architecture gets scaled up, and then a single VPC doesn't make sense for you. It might also be that you're needing to do a separation for environment. So maybe you need a production VPC, a dev VPC, or a test VPC, right? So that is a very common use case when you need to go with a multi VPC structure, right? Or you might need to divide VPC based on workloads, or based on teams, or based on compliances, right? That is a very common example. And why multi-VPC works? It works because you enable a least privilege design. So least privilege design means that you don't need to have all of the security, maybe broader security design for that single VPC. You can do a least privilege design per VPC, right? So let's say there is a team that only wants to restrict the VPC to say ABC person, right? But that is not possible because you are in a larger team. So you have multiple people using this VPC, right? So when you go to a multi VPC design, this is possible, which is a single VPC can be having a least privilege, another VPC can also least privilege. That is mostly a common example of why people prefer going with a multi VPC, so that they can maintain this least privilege design and also limit a blast radius, right? So this can also be useful, right? Because I don't want any implications of errors or issues within my dev to affect my production. So then I maybe keep them to both separate, right? So that will help ensure that this uh, blast radius is reduced, right? So when we try and look at a multi VPC design, right, uh, one of the biggest concern is how do these VPCs talk to each other, right? How are they connected with each other, right? So then you go with one option which is a VPC peering, but then there is another option which is a transit gateway, right? So both of them like apples to apples. The difference between each of them is a VPC peering is like a one-on-one direct connection from one VPC to another VPC. So that is the basic difference between it. Whereas with transit gateway, the difference is it is more of a hub and spoke, right? So which means that when you create a transit gateway, it can connect to multiple VPCs in a single go, right? So that is the design difference between both of them. In terms of scalability, when you try and do a one-on-one mapping between VPCs, it becomes complicated because multiple VPCs are there, each VPC needs to connect with one another, so it becomes a bit complicated in terms of scalability. But with Transit Gateway, it is simple to scale to maybe thousands of VPCs because it follows a hub and spoke model. So, which is a single transit gateway can connect multiple VPCs with each other, right? So then there is a transitive routing, which in a VPC peering is not possible, but with transit gateway it is possible. Another important thing is on-premise support. So I might have use cases where I need to connect my on-premise with my VPC. So with VPC peering, it is not possible. So I need to create a separate VPN and then connect VPN with my VPCs. That is the approach I would go with, right? But with Transit Gateway, I would directly natively be able to set up a Transit Gateway which will connect my on-prem and the number of VPCs within my AWS network. So again, advantage, right? But the cost is another factor, right? So now VPC peering is free to use, right? So there's no cost to peer one VPC with another VPC. But with Transit Gateway, there is some cost attached to it, right? So that is the difference between both of them. And VPC peering is manual per connection, so you have to manually set up them, whereas the transit gateway is more of a centralized thing, right? So the way I look at it, VPC peering works for lesser connections. So let's say I have 5 or 10 connections that I need to set up. VPC peering makes sense, right? Because you can do a one-to-one mapping, scalability is not an issue, and cost is also not there, right? But when it comes to scale, which is let's say I move on from 4 or 5 or 10 connections to more, then I will probably think about transit gateway because then I am able to bear the cost, but I also want scalability to be considered, right? So that is where I try and consider transit gateway. This is just an architecture to show you when a VPC is not enough. So if you look at this architecture, there is one region 1 and region 2. Region 1 has a VPC 1, A and VPC C. They are connected via VPC peering connection. And then there is in region 2, there is a VPC B and VPC D. Both again are connected via peering connection. A and we are also connected via peering connection. A and D is also connected or peering connection. C and D is also connected, and B and C is also connected. So this is how you have to set up a VPC connection, peering connection. The important thing to note here is all of these CIDR ranges are different. So you have 10.0, 10.1, 10.2, and 10.3, right? Because you cannot have the same CIDR ranges if you want to try and peer the connections, right? But if you look at this diagram, right, you have to do a lot of peerings: 1, 2, 3, 4, 5, and 6 to connect all of these four with each other. That is the uh, problem when it comes to using a VPC pairing. The other diagram that you see is of a transit gateway. So here you look at VPC A with VPC C and then VPC B with VPC D. They're all used via the transit gateway. So transit gateway can be set up, can be have a VPC attachment, and then VPC attachment is used to connect A and C. And similarly, you can use VPC B and D via the transit gateway. Now the thing is, if you have to connect VPC from one region to another region via the transit gateway option, you have to do a peering attachment. So transit gateway in a region one needs to connect with transit gateway in region two, then there has to be a peering attachment that has to be done. Right? Okay, so when I was talking about this VPCs, I said that VPCs need to be separate, right? So you don't need to have the same VPC IP. The ranges need to be separate so that you do a VPC peering or you do a VPC connection by the transit gateway, right? That is important to note. But another thing that is important to note is uh, you when in the initial sections also I discussed about this, which is are you designing your networking architecture for growth or you are designing it to fail, right? So the idea here is when you're trying to create your cider ranges, you're trying to identify whether this cider block will work for me or is it something that will not work for me, right? So maybe in cases I might say dev VPC needs to be a cider block of /16, right? And then the subnet range needs to be /24, right? So this means that your allocated IPs are going to be this much, and the used IPs maybe will be this much, right? So you need to plan it in that way that you are understanding that okay, whatever growth that the VPC or the architecture will have, I will be able to sustain or limit that growth, right? So that is how you plan about this cider ranges as well. I mentioned do not paint yourself into a /16 corner, which means that uh, while I understand that /16 is like a default that you might use, but don't always try and rely on /16. You can also be creative, right? So maybe I know that my architecture is going to be very limited, and I don't plan or don't have any goals of going beyond certain structure. Then why limit it to 16? I can go 24 also, or I can go higher, right? So that is how you have to structure it. Another important thing to look at is service discovery across VPCs. So you might come into issues where you have multiple VPCs and each VPC needs to point to a particular common record, so or maybe a common IP that needs to be resolved, right? So in that case you will probably use something called a route 53 resolver, and then so your on-prem device will query route 53 resolver. It will resolve to a hosted zone, and then hosted zone will return an IP which will again return to your device. So your VPC has or multiple VPCs can then access this hosted zone in that manner. So that is again uh, an important piece to look at in terms of a service discovery, right? Okay. So the next thing to look at is access patterns, right? So this again on a complicated level, because if you look at it, right, there are a region one and a region two, and it also includes some data centers, right? So this is just a very like a very complicated architecture for a specific use case, right? The use case is how do I connect my region 1 with region 2 and also have connectivity with the corporate data center 1 and 2, right? So here you use something like a transit gateway, right? So this transit gateway has connections from A and B, but also it has connections with C, which is in a separate region. And then you also are able to connect to your corporate data center 1 and 2, one via the VPN customer gateway, and two via the direct connect. So this is the entirety of a structure which is enabled by transit gateway, right? So when it comes to a certain scale, which is you need to connect to multiple VPCs, corporate data centers, and everything needs to fit in together, then transit gateway makes sense because you have this much of connections, this much of complexity. So yeah, that is how you look at it. Now, in terms of some best practices or some things to consider, so use transit gateway for large dynamic or multi-account environments, right? Multi-account is also important. If you have multi-account, then you might also consider transit gateway. Then isolate the sensitive workloads in dedicated VPCs. So again, this is important that if you have some sensitive workloads, you need a dedicated VPC for that, and then you can isolate it, right? Which is again limiting the blast radius or enforcing least privileges, right? The third thing is centralized shared services. So uh, again, there is a concept called shared services VPC, which means that if you have some common services like directory, logging, or monitoring, you would want to keep something called a shared services VPC, which will be connected via a transit gateway and will have all of your common shared services. So maybe, for example, this VPCA will be your shared services. So it will have all of your common services, and then transit via transit gateway, you are able to get access to all of these services, right? And again, this is something that I discussed, which is you should try and separate VPCs for each app/system. Maybe it is environments, maybe it is apps, maybe it is systems, right? Which helps you with fault isolation, right? Okay, so for the next demo, I think I just want to discuss on connecting VPCs using VPC peering or transitive, right? So I'll just try and open up and show you. Okay, so this has completed. Um, okay, first I'll just walk you through what has been done here, and then I'll go over and discuss the second demo, right? So if you look at this diagram, right, so you have a VPC, you have your subnets, and you have your route tables, and then there is a network connection, right? So in networking, there's an internet gateway, there's an ad gateway, there's a S3 endpoint, right? And this is your uh, US is to 1A, which is your upgrade zone 1, which has two public subnets. 1B has two. Uh, so this is one public subnet 1, public subnet 2, private subnet 1, and private subnet 2. Right? And then there is a route table, which is for, so there is a private route table for one, like for the first AZ, and then there's a route table for AZ2, and then there is a public route table, right? This is how the is structured. In terms of cider range is this. In terms of flow logs, you can create a flow log as well, right? Okay. If you go to subnets, you will see all of these subnets are mentioned here. And if you go to route tables, you'll also see the route tables mentioned here. Okay, cool. So now we want to look at VPC peering, right? Before we look at VPC peering, let's just maybe create or launch instances, one in each instance, right? Maybe I'll say EC2 1, and then I will create, I use a PEM. This is, I just want to understand. So this is a default VPC. I'm creating an instance in default VPC. Enable it, create a security group. SSH. I want to also add HTTP and HTTPS. Anywhere, and then I will also have HTTPS, and custom will be anywhere, right? So I'm just trying to create a EC2 instance with in the default VPC, and have inbound rules SSH, HTTP, HTTPS, and then in advanced things I will probably add the user data. I have a user data created. I'll just put it here. So what it's saying is it will first do an installation, and then it will print a hello world message, right? Just launching this instance. I'll also now go on and create another instance called EC2 2, and then it will also have my PAM, and I will change this to project VPC, and then it will have, it will be in the public subnet, right? And then we'll call launch 5, add security groups. I will say HTTP and anywhere, and then also add HTTPS, and it also be anywhere. And then I will also add a component which is like hello world and launch the instance. Okay, so let's see, both of the instances should be launched. This is EC21, it is initializing. Connect, and connect with it, and I should be able to get to the, okay. Okay, so this is the message that I'm getting for that particular EC2 instance. We'll wait for the second EC2 to be created, and I'm also going to be connecting. Okay, no public IP, so you need to add a public IP. Second. Okay, this doesn't have a public IPv. It is something we might have missed. Let me just create another EC2 instance. EC2. Right, this was disabled. That was why this was the issue was happening. I just enable it and then create another instance. I could have gone and changed it, but then I don't want to. I can add it in here. Sorry. Okay, cool. So this is where I've connected. Now the EC2 3 is getting created. Let's wait for that to be created. And till then we can go to peering. We can go to peering connections, and I can maybe create a peering, right? So I'll say uh, VPC my default to project VPC peering. Okay, uh, default to project VPC peering. Right, requester is default, and then acceptor is project VPC. Okay, right. So this is there's it has requested it, and then I can also accept the request, right? Which means that it has been accepted. So peering connection has been set, created from a default VPC to a project VPC. I had two VPCs I had discussed, right? Which is I can show you this one, a project VPC and default VPC, correct? And then I created a peering connection from default to project VPC, right? Now I have to modify the tables, right? Here I go in this and I go edit routes, and then I add something called if the request comes from 10.0.0.0/16, then it goes to peering connection, and then this one, and then save changes. Right? I need to check the other route table. Let me see here. Okay, and this one has resource map. Okay, I'm editing routes here, and I am adding something called 7. I need to first copy it. Let me just copy this. So this is what I'm copying. If request comes from here, if it is a peering connection, and save changes. Okay, cool. So yeah, I have. Let me also copy and paste it. Okay, so both of them have their own IPVs that are being displayed here. I'm in the EC2 one. Let me also connect and go inside the EC2. Connect. Okay, perfect. So now I'm in ECT3, and let's say call, and I'm trying to private IP. Okay, so what I'm trying to do here is I just try and explain everyone for some context. So I have created two EC2 instances, EC2 1 and EC2 3, right? EC2 1 is in a VPC default, and EC2 3 is in the VPC, which is the one that I created recently, right? So I have EC2 instances in two different VPCs, okay? Then I created a VPC peering, And these two EC2 1 and EC2 3 have their own public IP, right? So I can see them, the hello world message which is being displayed here, right? Then what I tried to do is I tried to create a VPC peering, right? I did create a VPC peering, and then I tried to also attach it to the route tables, right? So you can see both of them route tables were created, right? So a peering connection was set up, that is what you can see here. And then I also did add the route tables, right? In the route tables I had to add that, hey, if the request comes from this particular 10.0.c, allow it, and if it comes from 17. This, then also allow it, right? That is how I had to set it up in the route tables itself. And then the next bit of it was I tried to do a call command, right? So I tried to call from uh, the EC2. Okay, so I'm in EC2 3. I tried to do a call command to the EC2 1, right? It's not going to happen because it's a private IP, right? You cannot be able to connect to it. Uh, if I go to EC2 1, which is here, and I do try to do a call, and then probably I'll do the IPv of 3, right? So IPv of 3 is 10, and try and do this, plain text. It's also not going to happen, right? Because both of them are trying to connect to the private IP of the other instances, right? Which is not possible because you only have public access, right? Now, once I do a peering connection, then I'll be able to test it out, right? So I've done the peering connection, right? And I have to now add the specific route tables, right? So let's just go on and see, right? So this is the peering connection that has been set up for this particular example. Let me just go on. Okay. Sorry. Okay, you see this message, right? Which is you're able to call. And if you do this, okay, yep. So this means that your VPC connection is working and you're able to call it, right? Perfect. So this was the second demo that I wanted to show, connecting VPC using VPC peering. Okay. Uh, and again, present. Okay, so the third layer that I wanted to discuss is enterprise grade security and observability, right? So here, the couple of components here, right? So how do you ensure security best practices are followed for your AWS networks? So one thing you can do is least privilege IAM roles and strong identity. So you have to enforce these things. Second thing that you can do is you can have security groups and knuckles on this layer, right? So we discuss security groups, we discuss knuckle, one being stateful, one being stateless. So these security groups and knuckles can be a very good addition to your security best practices. Third thing that you can look at is encrypting data at rest and in transit, right? So using something like KMS, using something like TLS can be helpful to encrypt your data, right? And then the fourth bit is using services like AWS config rules and guard duty. These services basically help you with real-time compliance and threat detection, which again will help you in building a security perspective for your AWS networks, right? The final bit, which I think most people try and forget, is you have to regularly review and audit your security policies, right? That is very important to do. These are the couple of services and what are the use cases for that, right? So VPC flow logs, and VPC flow logs is for capturing all of your accepted, rejected traffic, which is again for your auditing purposes. So it can help you understand, okay, what is the request that is accepted, what is the request that is maybe denied. So that is very helpful in terms of observability. Then network access analyzer, again, to understand if there is something which is detected, unintended access, right? So all of this can be checked and verified using the network access analyzer. The next thing to look at is traffic mirroring, which again helps you understand the intrusion and detect it. The fourth bit, which I was talking about, is guard duty and security hub for alerting and security purposes. And again, the fifth one, which is very important, is CloudTrail, right? Now, how CloudTech works is you're able to audit and understand all of the different things that are happening within your AWS account using something called a cloud drive, right? It logs and reviews all of your networking resource changes and usages, right? So in terms of, we discussed security, right? What are the different services that you can use for security purposes? In terms of observability, you can use something like CloudWatch, right? So your logs, your metrics, all of them you can put in CloudWatch and have your security hub take actionable insights from it, right? You can also integrate event alerts with Event Bridge. You can also use reachability analyzer that I was talking about to understand the live path, right? So whenever a request goes from here to here, how does it go, right? What are the different paths it takes, right? So all of it is possible with observability, right? So for the demo three, which is how do you monitor a failed access attempt to a subnet with VPC flow logs and alert via CloudWatch. I don't have it ready with me as of now, but you can go to two links I have. One is called the routing loop, and one is called the demo. I'm just keeping it open here, so you can scan those QR codes and try and access these demos, right? So routing loop is an AWS initiative. So AWS has a Twitch show called Routing Loop, which is again mostly around networking. So you'll see a different sessions that happen each week or each month. They're all based on networking, right? So different components within networking are covered within each session. And so you just scan it, you can go to the routing loop, and you'll see a different list of sessions. Demo 3 is basically specific to your CloudWatch insights that you get from VPC flow logs, right? So I'll just show you since I can so open up and show you. Uh, First thing is, where do you find VPC flow log and how do you enable it, right? So here it is, VPC flow log. Create a flow log. You name it. You have all the requests. You have the aggregation, and then you can put it in a CloudWatch log, and then you can also have a format of it, right? So this is how you can create a VPC flow log. I'll go to CloudWatch and show you how it can be accessed, right? There is something called log insights. You just click on log insights in CloudWatch, and you will see your log insights can be shown here, but you can also analyze it here, right? So here you can see VPC flow logs, right? So when you create a dashboard, you're basically creating a dashboard from your VPC flow logs, and then you can basically able to see it, right? So this is a very common example. Okay, so this is a very common example of how you are able to monitor your failed access attempts in your subnets. So your VPC flow log is basically able to log your request and then send it to CloudWatch. And within your CloudWatch, using this option, you're able to see your request, right? So that is the demo three. I You can just scan your code here, and you're able to see the demo three. Uh, I know my time has been passed, but I'll just wrap it up with few things. Last few things are there in this particular session. I'll just, sorry. Yeah. So advanced connectivity patterns. I don't want to cover a lot of these advanced concepts, but just something to be aware about is VPC peering. I discussed about that. One-to-one connection, transit gateway, scalable VPC. It is an hub and scope model. Then there are different other components like Cloud WAN, private link, direct connect, site to site, right? So each of them has a different purposes, right? So your Cloud WAN has multi-region. Your private link is basically private access to your services. Direct connect is basically a dedicated line from your on-premise to AWS, correct? And your site to site is also fast, secure, and interbase your connection from your on-premise to AWS. Again, it is not a dedicated line, but it is more of a connection request, right? So these are all the different connectivity options. Again, these are all advanced concepts, right? So you would use a direct connect in very specific scenarios. You would use a site-to-site in very specific scenarios. You use a private link in very specific scenarios, right? They're not your very common use cases or common usage patterns, right? So this is a difference between direct connect and site to site. I was discussing, right? Both of them are connecting on-prem to AWS, right? So your direct connect is like a dedicated private line, whereas a site to site is encrypted on the internet, right? Bandwidth is more indirect connect. Cost is also more indirect connect. So it depends on that, right? And then use cases is maybe you need to do a quick connect from on-prem to AWS. You will use a side to side. Maybe you are looking at a backup and DR side to side. If you have something which is mission critical, needs very high bandwidth, maybe direct connect makes sense, right? So that is the basic difference. This is more of a diagram to understand private link. So if you have your EC2 instances, you use a private link to connect to maybe another AWS services like API Gateway S3, or maybe services in another account, right? So that is kind of a use case of using a private connect, right? You don't want to have a public exposure to the services, right? So that is where you would use something like private connect. Uh, Again, I will skip these portions for now, but just for your references, VPC flow logs, reachability analyzer, and routability query logs, all of these are more of advanced topics for observability and understanding more about your security, like more about your decision that your networking has made. So let's say there are some issues within networking. I'm not able to reach from A to B, then I can basically go into the flow logs or reachability analyzer or output the query logs and understand why the A request is not reaching B, what are the different issues that I'm facing, right? So all of this is more from an advanced observability patterns. So I'll probably just skip it for now, right? So they're all advanced concepts, right? Uh, so now just coming on to the architecture that I wanted to discuss. So this is the architecture I wanted to discuss, right? So you look at it, right? Your VPC, your here you see your VPC, right? So your public subnets, one to private subnets, right? All of this we discuss. We discuss internet gateway, we discuss NAT gateway, and we also discuss multi VPC, right? So now in multi VPC we discussed VPC peering, we discussed VPC gateway, we discussed direct connect, though we didn't discuss direct connect that much. Then transit gateway, we discussed transit gateway, right? So this is the different concepts. Shared access, we discuss interface endpoint, we discussed gateway endpoint. Gateway endpoint is for S3s and DynamoDBs, and interface endpoint is for other AWS services, right? And for hybrid, we also discuss, so yeah, this direct connect and the side to side VPN is all about hybrid, right? One important thing that I didn't discuss in the overall architecture was VPC lattice. I think hopefully in the next session you will get more insights from VPC lattice. Okay, so just to wrap up the session, couple of concepts, right? So peering, for fewer VPCs, you can use peering. For more than 10 VPCs, you should use transit gateway. Peering is not for centralized access. Transit gateway is for hybrid connectivity. Transit gateway makes sense. Cross account sharing. Transit gateway makes sense, right? So this is just a uh, diagram or a differentiation between peering and transit gateway and what should work for what, right? A couple of things to make sure: have tight cider blocks, limit future VPC and subnets, do not misconfigure security groups and knackles, because you will not be able to know what happened within your account if these are misconfigured. And observability is something that you should try and do initially itself. Enable VPC flow logs, enable the different other observability patterns like CloudWatch and other things to understand what is happening within your networks, right? So these are the three important things to know. Blocks need to be limited. Do not misconfigure your security groups and knackles, and then you also have to have observability. Okay, so yeah, so in terms of what you need to do in terms of the challenge, there are three screenshots that you can see here. So first challenge is redesign a VPC from scratch. So the link is for a workshop within AWS. So you can scan this link and you can go to the workshop, try and create a VPC from scratch. So do not create a VPC directly using the option that I was showing you, which is just do a click ops and the VPC is created, but create individual components separately. So what I mean is create a VPC, then create maybe subnets, then create maybe route table, then create maybe security groups. So go with that option, right? Second thing is play with reachability analyzer. This is again for your observability within your networking. And then third thing is check out the routing loop, right? Routing loop is the Twitch show that I was talking about. Go check it out. It has good sessions and good important understanding of your AWS networking concepts, right? So yeah, I think that should be all from my side. Thank you everyone for joining my session, and I hope you all got value from this session. In case you have any questions, do let me know. I'm here on this, so I can help you with that.
Yeah. Thank you, Adit. That was a wonderful session on the networking basics, and you covered a very good number of services and how we should implement them in the very best way. So thank you for that. So due to short of time, we'll take one or two questions, and we'll go to the next session. So first one, uh, I'm popping up it in your screen.
Okay. Yes, cider management are always hectic all these days. I recently started using IPM. This made everyone's life easy. Yeah. So thank you, Raj, for this. So I think most of the people that are using networking or trying to do networking these days find CIDR management very tricky. So what Raj mentioned is a very good option, which is like IPM. So you go to reachability analyzer, you create an IPM, and this IPM basically ensures all of your CIDR management is something which is displayed and visible to you. So your IP ranges, your public IPv, elastic IPv, everything is in this IPM. So definitely something to try out. So yeah, do try this out, which is good, helpful for you. I think it's not charging you also.
Hmm.
uh,
And the other
Another
one, same
question.
from Raj.
Yeah, when logs are stored in same AWS account, in case account is compromised, logs will be flushed by hacker. It's always recommended to publish logs in a separate account. Again, very very good insights, which is uh, and we generally have in AWS account, we don't have logs stored in that account. So any of your networking VPC flow logs is well, right? So I was talking about VPC flow logs. So your VPC flow logs shouldn't be stored in your same AWS account. It should be stored in a separate AWS account. So again, a good best practices guide from Raj, both IPM and storing logs in a separate account are, I think, the best practice we should be following.
Yes. So thank you, Adit, for joining us. So
Yeah. Thank you,
thank
Pubalan and AWS User Group Madurai for having me on the session.
Yeah. So if anyone has any questions or wanted to ask something to Adit, you can directly reach out to him on LinkedIn. So he'll be happy to help you out. So thank you,
Sure.
guys. So now I welcome Srinivasan. So Srinivasan is a cloud architect at PwC. He's also like 9x AWS certified. So he's going to walk us today about AWS VPC Lattice. So which Adit was mentioning in his earlier session, like he gave a small peek into it, but Srinivasan is going to dive deep into how we can use Lattice. So hi Srinivasan. So you can get started.
Hi, Bhavan. Hope you can hear me clearly.
Yes, you're loud and clear.
Yeah. Thank you, Bhavan, for the opportunity. And hello, all. Good afternoon. First of all, welcome to join this session. I know it's Sunday. There were a lot of other fun facts hanging there, but having you dedicate some time to learn something on this Sunday is always good. So, without further ado, I'll just kickstart my presentation. I hope you all should be able to see my screen now. We can give some thumbs up or a note that it's visible.
Yes, your screen is visible and you're good to go.
Yeah, good. So let's start. So today's topic is going to be on a VPC lattice. So I know many of you would have gone through the VPC console in AWS. You just scroll through and you found this one word VPC lattice. But around 70 to 80% of the enterprises doesn't switch to this at this point in time, which is a wonderful service, and we'll discuss and go deep in it how is a good alternative for transit gateway and VPC pairing and where we should use it. So these are the key points that we will discuss today. We'll start with networking foundations. Adit, in the previous session, almost covered basic of it. I'll just go through in a flash of few seconds, and then we will stress more on network segmentation, why that is important in the modern times, and most also in the cloud computing era. We'll go deeper into VPC lattice, its full composition, what are the different key components in VPC lattice, how it is helping the networking, how it simplifies the connectivity, all those stuff in all levels. I have a couple of use cases as well. I put up pre-built templates in one of my maybe around three accounts. We'll see that. And the governance part of it, if you want to deploy this VPC lattice, what are the steps that not only as a network administrator team, but also as an application team, how we would need to leverage that. We'll look into that. And how to transition from a normal VPC setup to a VPC lattice setup for some of your workloads. And we'll touch upon the VPC lattice pricing. So though all the feature looks good, also we need to touch upon how what is the pricing component for it. We'll look into that. And then finally, we'll have a key takeaways of this meeting, what you are expected to take out from this meeting. And we'll have a Q&A session as well going forward. Good. Okay, foundations. I hope all of you could able to relate this diagram with a few of the sparks, maybe experienced persons, or also in the group, also the newly joined engineers. But still, whenever you create when you want to play with the EC2 machine and the account, the first thing that you do is go and provision a small VPC, be a three-tier VPC, and to play with the pairing connection, you'll at least have two VPCs. But the key components are like you will have always have an AWS account and a VPC, which is an isolated environment to host these workloads. And the moment VPC comes, it also comes with the internet gateway so that the workloads can talk to the internet, get some plugins, packages, whatnot. And maybe the initial exploration phase, you may be happy with the pairing connection where it can connect two VPCs. But down the line, when you go to enterprise environments or in a real company setup, even a startup would have at least 10 to 12 VPCs easily based on the number of application and their landscape. So the transit gateway gets more important, which gives us a full mesh connectivity. Then next one comes the direct connect. Everyone doesn't start fully in the cloud, so they do have their landscape in the on-premises. So there has to be means to connect your on-premises workloads to the AWS, and that happens via direct connect. You set up a highly dedicated low latency connection from AWS to the on-premises network. So these are all the foundations, and let's go into the network segmentation. So as we go and create more networks, the segmentation of it gets more key because it depends on the risk depends on how much exposure you give to your workloads. So that's why you have the subnets. The concept of subnets was also there in the on-premises. You have multiple VLANs, so you logically group the host uh, in the on-premises. The same also applicable in the AWS data center, which is AWS cloud. You try to segment the given IP range, and typically it all starts with web subnet, app subnet, data subnet. So you put your public-facing applications and web subnet. You have your internet gateway there to reach out, and you'll have a private subnets, couple of them, one for the application subnet, where you put your typical application servers, which will not be exposed publicly, but it gets it route via the NAT gateway. Then for a typical three-tier architecture, you also have a host to database, and database will never sit on web subnet given its confidentiality. So you'll have a separate data subnet, and you'll have a lot of restricting mechanisms, I would say. So it all starts with route tables. So each subnet it gets its way how to reach out to the internet for a different network path for a given destination. So when you see the route tables for any public subnet or a private subnet, you will have the VPC ranges local 10.101.0.021 here, which will give you around 2000 IP ranges within the VPC. It is always going to be local. So the host in this VPC can talk to another host unless the security group blocks it. So there is a by default local path set. and you cannot modify this by any chance. Next one is on the private subnet. You can see the 0.0.0. So anything other than this location goes to NAT gateway. So NAT gateway does the network translation. It keeps your private IPs within E1. It won't reveal it to the public internet. And but it still sends you the gives you room for internet access. And you have a knuckles in place. So knuckles are stateless. So you have to have the inbound outbound rule specified to get the traffic easily passed through. So other than this knuckle, whenever you put a compute, it can be a EC2 instance, it can be a Lambda. You can always choose a security groups for it. That security group acts as a firewall for that specific device. What are the network packets, network path that this compute can listen in from? So that's security groups. And in a typical three-tier architecture with just one VPC, security group is the only protective layer. If a security layer can get tampered, then it almost that your instance are very vulnerable. And it will be mostly within your subnet because you'll have a knuckles in place, but still knuckles are not leveraged every time in any enterprise setup as well. Now moving forward, think about it network segmentation at scale. So the first slide, the previous slide, it talks about one VPC only. But in enterprises, right, you'll have hundreds of VPCs easily because you have multiple accounts as well. First, accounts are your permission boundary to logically group your resources. But then accounts comes with VPC as well. So you have multiple applications. Each application has its own environment, dev, test, prod environments, sometimes integration, staging, whatnot. So you'll have multiple VPCs, and mostly all of them has to be talk to each other. If not, the dev VPC for one application has to talk to dev VPC for another application. So the full mesh connectivity is almost needed here. So that's why the transit gateway comes in here. So when transit gateway pitches in, then you need to see the routes from one VPC to the other. And here I given a quick screenshot of the transit gateway route table. And you see the difference between a individual route table here, where you have the path only to 0.0.0 and a local path of this VPC. In case in a transit gateway route table, you can see the address path to reach, for example, if the VPC A wants to talk to workload and VPC C, what is the route that it has to take? And there are a lot of differentiation between the propagator route and associated route. Let's not go into that deep, but this level of segmentation is key, and it can be seen in any AWS environment when you have at least 5 accounts. So this segmentation gives you more access from one VPC to other, also the vulnerability as well. So the only the gateway, so the transit gateway route tables are the path to reach from one account to other account. And for example, a workload in the app subnet on VPC A wants to talk to app subnet in VPC B. As long as your security group allows it, it can talk. But as this VPC keeps increasing every day, you have to spend more time on the updating or adding new entries to this transit gateway route table. And also remind that workloads doesn't talk via IPs, they talk via DNS name. So you also have a Route 53 integrated into your account, and it provides resolution from the friendly name to an IP address. And this is now within the company, but you wanted to talk to the internet or you have some public facing applications. Then you have to inspect the traffic for both the traffic coming into the application and traffic going out of the your workload. So there has to be a traffic inspection in place where your AWS firewall manager will come in. It can be direct AWS offering, or it can be a state of the art firewall, Cisco firewall or a Palo Alto firewall. But there has to be a firewall there and multiple other protective shields for your public facing applications. It can be a WAF or it can be Akamai, it can be CloudFront. There are multiple ways to protect your network. And finally, the flow logs, which can trace all the network information happening between the accounts. So, having said all that, you still have a networking segmentation at scale, but still, for every new VPC, you have to manually manage this transit gateway router because that's a complex hub and it gives connection to the on-premises via direct connect as well. So, though you modernize, migrate workloads from data center to cloud, still there could be some complex compliance and statutory requirements to keep some of the devices in cloud, in data center. So this connection is also mandatory, direct connect one. Now let's go to VPC lattice. So how this is going to be different from the previous one? Because this particular architecture, right, the transit gateway, it works well for the past 10 years, and it will be there for another eternity as well. But what is the unique advantage that VPC lattice gives us? Because this is an application layer networking service. That means you can talk between services. You don't need to have a separate route table entry, separate work to add to DNS. It's all handled and managed by AWS. The complete route has been established by AWS, and it is built on zero trust networking architecture principles. That means it never trust anyone, always verify them. That's a key, one of the key principles in zero trust. So though the security group allows it and the transit gateway route table allows it, you are considering your IP addresses as your identity frameworks. There is no check made on who is using that IP. Is there any bad actor using that compute to make your infrastructure vulnerable? There's no check on that in the current setup here in this particular scalable architecture. So that's where you will have more options or more layouts or frameworks to validate your traffic before opening up the connection with ports. So that's why this VPC address is very helpful tool, and it has four key components. First one is service. Service is nothing but your workloads that you want to expose for the other user or other workload, other any other workload in your environment. Next one is service networks. It's a collection of services that you group together as kind of a namespaces in a DevOps term. And authorization policies. This is nothing but your IAM based policies. So we don't trust just the route table entries or DNS. We also ask for a IAM role or IAM based policies. And finally, a service directory. It holds all the information. What is the service name? What is the DNS name? How to route the traffic. These four will be the key pillars of this VPC lattice. So let's go into each of them one by one. Let's take lattice service. So the service is nothing but an abstraction of your application. So you can have your application running on an EC2 machine. You can have a Tomcat server or Apache server, or you have a simple Flask application also fine. If you're running the application there, that's a workload, right? And you can run on a serverless compute as well, or you can have a ECS Fargate based deployment and you host it behind a load balancer. Or sometimes you have a very fixed static IP addresses. So all these can be target groups to become a service, and all of them you would have seen uh, when you would have worked in a EC2 load balancing service. The name is same, it's going to be the target groups. And the way how we set up VPC lattice service is that you have to select a listener first, which port you want to talk, 80443 or any other TLS ports. And optionally, you can choose the rules as well if you want a path based or header based routing. And finally, the target groups. So if you just follow these three steps, then you can create a VPC lattice. And the moment you create a VPC lattice, it also gives you a nice DNS name uh, by default. And the second key component is service network. So now we created one service, but it is not enough for an enterprise, right? You can create multiple services based on the requirement, and you can club all these services into kind of a namespaces, which is called as a service networks, because it enables the connectivity between them or a kind of a grouping. So it doesn't mean that as and when you add more services to a service network, it can talk within each other. It is based on a kind of a producer and consumer kind of a model. And these service networks can be shared with multiple other accounts in your organization through resource access manager. Just try to relate the service network to a transit gateway. So transit gateway allows you to connect multiple VPCs, right? Similarly, you can associate your VPC to this particular service network so that you get access to a specific service. And the routing is taken care in the backend. I'll show you in the console as well in a few minutes. And the third key pillar was the IAM policies. So the latest service and the latest service network both can be added with a request all authentication. So you can see here this is the IAM based resource based policy. That will be giving action like lattice service invoke action on any principal, provided that that principal also there, these two accounts. I have two sample accounts to show demo. I have provision lattice services there, and these two accounts are consuming it. So I'm whitelisting that. Even though I have 100 accounts in my enterprise setup, I just only want these two accounts to use my lattice service. Again, we can go like fine grain policies we can do. If you have a big load balancer and then you have a get request, you have a post request. Get should be allowed for all, but post and put should be restricted for someone. So these fine-grained authorization policies are there, which will help us to get a context of the user who is trying to reach to our workload. Then fourth one is the service discovery. So the moment you create lattice services, lattice VPC lattice service, right, it will give you a nice DNS name. Yeah, it cannot be said nice. You'll have a name of the service followed by a hash code, followed by a service name, and then region name, and then dot AWS. This may not be so friendly, but there's other options that you can establish a private hosted zone, add this name to a friendly CNAME or alias, and then call through it. But which is a lattice service itself, it has all the directory of complete domain name it has. And this again, it can be shared with RAM. So any service shared with your account gets popped up here and it be a part of your service discovery. And yeah, I mentioned this as well, right? Custom domain name is possible. No one wants to call the service in this big name, but yeah, that's possible with Route 53. And earlier I mentioned that this is zero trust network architecture. You can see here, one of the key principle there is layered network security, because we are just exposing our workload as services, but how about the routing? We never talked about it, right? Because the routing will be handled by AWS managed prefix list. I'm sorry, yeah, AWS managed prefix list. So the moment you create a service network and associate your VPC, VPC lattice service will put two additional entries to your route table, and the target is VPC lattice. You have a IPv6 address and IPv4 address. This address is fully on AWS backbone network fabric, and the traffic or the transport between your account and your VPC to this particular IP address will be fully encrypted in TLS mode, end-to-end encryption, both in rest and in transit. That way, it also follows the zero trust network architecture principle. And we can see here there is a kind of a three-layered approach here. Because first it starts with the VPC association. You remember this slide, right? You talk about service network and you associate with VPCs. So only VPC that has association to the service network can talk. So even if there are 100 VPCs, if it doesn't have association, then it cannot talk to the service backend. That's one layer. Second layer is that on every VPC association, you can choose a specific security group, and this security group, you can choose a specific IP range, even though you have a /21 range here, which is 2000 IPs, but you can pick and choose specific IPs that I want to allow to talk to this service. That becomes your second layer of control. And third layer could be the IAM role that we saw there, restricting only to a couple of accounts. We can also restrict by the instance profile that EC2 users or a Lambda role that's been accessed. So there are a lot of flexibilities there. That's why we call it like layered network security. And you have a three-layer architecture here. And so by the name VPC lattice, right? If you remember organic chemistry, would have the atoms and then covalent bonds between them. Something reflects that. You have VPC association. And then if the traffic passes this particular layer, then it comes to the security group layer. And if a security group also approves the traffic or it's whitelisted, then it checks for IAM authorization. And if IAM policies are good, then the traffic flows through and reaches the final target. That will be your service, which is Ocean, as a part of target group. Now, let's see a quick demo of this. I've pre-built the solution on the account because it's, like it's very difficult to create a VPC in the runtime and have all these instances set up. I'll show what I've done. Yeah, I'll just pull up a architecture diagram to show you that. So if you see, here is the architecture diagram that I put, and I have around three accounts: account A, account B, and a final account which is called as a, let me zoom in a bit. Yeah, you can see here. app claims prod account, and you have VPC in US East 1 region on like in the range of 10.101./21. You have three subnets here: web subnet, app subnet, and data subnet. And I don't have any transit gateway arrangement here. If that is the case, then I have to put a transit gateway subnet as well. But for now, I have only three subnets, and that you can see here. You go to the VPC section. You can see here, right? App client for VPC 10.101/21, and you should have a relevant subnets as well for it. We'll have six subnets, right? In both AZs, web subnet, couple of web subnets, couple of app subnets, and a couple of data subnets. They have those six subnets as well. The complete range that you can see here. And I have put a small instance there, compute, named as planes for workload 01. And I'm a developer working on configuring this machine, and I don't want to learn anything very deep on networking. I just want to expose this particular service. And hence, I created this machine that you can see here, right? This is instance app clients prod workload 01. A few other machines running on, but this is the one which I have put some workload and it's running there now. And I also have a Lambda function. This compute on this Lambda is just simulated just to show you how the networking works. I just put app recent transactions. It could be dump static data just to give you some last five transactions. But in practicality, you can have your functional code here. You can have a database, a data subnet. You can have logic setup, try to pull data, pull and push data all through the thing. But now I'm just showing you how the network layer works. So you have a lambda function as well here, okay, and you have an instance. Now you can register these both workloads under VPC lattice service. What you have to do is that you have to go to the VPC console, go to lattice services here, and now you can see there are two services added. I'll just show how these services are added. I will just show be creating a new service, but I'll not fully create, but I'll just show what all the inputs it needed. So you can just give a test name, you can just give a service name. I'm just giving a test. And then you can choose a domain configuration FQDN. So by end of creating this VPC lattice service, it gives you a DNS name. So AWS asks, can I generate a name for you, or you would like to have a custom domain name? So if you have some custom name as per a company, that you can provide it here and manage the certificates for them as well. But here I will just go with user generated domain. And then the service access, how you want to expose the service, whether you want to authenticate with IAM or you just don't want to do that. Just open it if the security group matches. And then if you choose IAM, then you can provide your IAM policy, how you wanted to validate the input first. And then you just keep going next. You can have a routing listener. Here is where the listener in my slide come up. So you can choose the listener. You want HTTP, HTTPS. You can choose be port 80 or port 443. You can choose that. And then if you want to have you can choose the rules, like the rule based, like if you want to have path-based routing or a header based routing, you can do all of them. And you can do the weighting as well, like the weighted record. 20% of traffic should go to the first target, rest has to go to second target. Those kind of weighted routing, canary deployments, all those are possible here. And then finally, you have to choose a target group where you want to send. That you have to have it ready. I have had to, but I have all the two I have assumed it for my other service, so it's not coming up. But here, but that's the case. But you can create a new target group here, and this target group is similar to your console that you see when you create a load balancer. Because when you go to VPC console, you can see there's a target group here, and also if you go to EC2 console, you can see there's a target group here. Both are literally the same. Okay. It's just that if you create a target group here, you can assign it to your load balancer. And if you create a target group in the VPC console, okay, what is VPC console here? If you create a VPC console, then you can use it for your lattice service. So I created two target groups here. I just show one how it is created. So I just registered my instance ID, that is apps claims prod workload 01 and the port 80. All should be looking good. Health checks are on and they're healthy. I have monitoring and slash welcome path my application. Targets are healthy, status is active, and this target group is now attached to my lattice service. The first one, app claims for transaction service. And you can see the association here. And the routing again, it comes from the listener. We have open port 80 for it. Port 80 forward to the respective target group. And for now, I just get access as it should only be accessed from a specific VPC. That's on another account, which I will show now. And you can comes with by default CloudWatch monitoring. But I have also wanted to trace the logs. So I send it to CloudWatch log group. That's here, demo VPC latest log group. So you can trace your incoming network packets to this particular service endpoint. You can see the log streams here. What is the service network it is associated with? Who is listening to it? What is the target IR? What is the source code, target port? So you can see all the information as a form of logs as well here. And finally, you can see the sharing if this particular service has been shared with some other account or not. But similarly, I have created two services. One is for this workload, and another one is for the Lambda function. You can see here recent transactions. That is for this particular Lambda function. Similar way, routing. In the routing, just choose the listener 80, and then you choose the type as Lambda, and then you give it as a specific. You choose a specific target group. It will be Lambda. And for now, I didn't keep any access here. I just want to show one access, one without access, or without IAM access. So it should all be good. And for each of these two services, you have a DNS name here, right? Now we saw the first component. Second one was service networks that you can see immediately above this particular one. And if you see here, we have a service network. It's a collection of services. So I have associated both of my services, the transaction service and recent transactions, and EC2 machine and the Lambda. Both are associated with this service network, and this service network will be shared with other accounts. If you now go for the resource access manager, you can see here that shared by me, resource shares, you can see VPC lattice share. Here, I have shared these two resources. One is the service, another is service network to the principal. The principal is 263. This is another account ID. I have shared these two resources with that account. Now, if I go to this account, 2636, I should be able to see my service network, right? Now, let me go to that account. You can see the 2636 here, right? Okay, the logo is blocking here. Now you can see that 2636. This is the account. Then this account, I have few machines running for my personal study, but yeah, this is the key machine that I wanted to check. App finance fraud, other one was app claims fraud. So from this machine, I want to reach to that particular machine without setting a routing or a transit gateway or a VPC pairing by a VPC lattice service. But before going deep, let's go to the RAM and see whether I have received the share from it. Now I am in the resource access manager. Shared with me, you can go to the resource shares. You can see that VPC lattice share, it has been shared from this account 1545, right? Now you can see what are the resources have been shared. You have a service, you have a service center. Both are shared with this account. Now go to the VPC console and we go to the service networks, which are already there, fortunately. You can see the particular service network, right? Which I can show in the other account now. This is the first account. App clients pro transactions. The same service network is popping up in the Microsoft Edge browser now with a different account. And here I can associate my VPCs from this account. Now the third part comes in the VPC association, right? As per our architecture diagram, which is this diagram, right? Now your service networks has been shared with one of the account, correct? This account, App Finance Pro account. We have a App Finance Pro server here. Now this sharing is been done. So now if I log into this particular compute machine and try to hit the DNS name of this particular service, right? Then I should be able to talk to it. Or in case both services, because service network has permission to talk to both services, so I should be able to talk to the compute and the Lambda from this particular EC2 machine, right? Right. Okay. Good. Now we have to make a VPC association first, which already I have it now. You can see here. That's VPC association. And there you can see the VPC ID that ends with 7B45. That's a part of this account. 7B45, right? So there VPC 10.10/24 slider range and is associated. While making VPC association, we can also do the security group association because it's a VPC with /24 range that is close to 256 IP ranges. But the intention of going to VPC lattice is to have more segmentation and have a zero trust network architecture, right? I don't know to move this thing up. Right. So I don't want to whitelist the complete range, but I want a specific machine in my EC2, that's the App Finance Prod machine, to talk to the service on the another account. So maybe I can just whitelist this particular IP range. This machine should have a private IP, right? I can just whitelist this private IP, or if we have a, if we know that only the machines in the app subnet will talk to that particular service, instead of whitelisting the complete VPC range, just go for a subnet, go for an app subnet, and take that particular IP range, and then just block it on the US East 1A, and then whitelist only this particular range in the security group that you can see here, 6209A. Here I have allowed only the port 80 connection from this range, is 10.1.0 128/28. So this is a subnet range of this private app subnet. So the host, so from this particular VPC, any host from this particular range can talk to this service network and can go out of this VPC and can talk to the server in this particular VPC, all through AWS backbone without you having to go and modify the route tables, transit gateway, attachment, all those stuffs. These are not needed. Let me show that. I'll go to this account now, get to the server. I'll connect the server via the session manager. Now I want to know the DNS name, right? Which I should be knowing it. So, sorry, this account. I'll go to the VPC lattice service, EC2 lattice service. So for now, we have this only the AWS given domain name, but in an enterprise setup, you will have a VPC with Route 53 enabled, and you have to have a proper private hosted zone based on your domain name, whether you're doing for transactions, for payments, for claims, for orders, whatnot. You'll have a separate VPC and you'll have a route table. Sorry, you will have a Route 53 and all the DNS records. So for now, I'll just use this particular domain name. I just copied it. I'll do the call command from here, try to ping that particular service, and I should get a response. I've got it. I just put a small Python Flask application there. I'm not a developer though, just to prove my network connectivity. I have a Flask application. With three simple endpoints, we have just type claims. I have put some three sample responses, approved, pending, rejected. And I can put transactions. Now we should get three transactions: credit, debit, credit. This is output from that particular machine, right? Now if you go to that account and you have enabled the monitoring. Now if you go to the CloudWatch logs, taking a while. And now you could see, you can see here, right? The source VPC is 2636, and this is the source IP port, and there's a communication established now. And you can see very minimal logs here, but we know the intended participant or the recipient of our VPC. So now we have tried this EC2. Let's try this lambda as well. It's a lambda function here, right? We'll try this lambda too. So okay, so I go to again VPC lattice service, take the second DN domain name here, and then go to the first server here and do a call command. Well, just you'll have last five transactions in database successfully. This is static data coming from that lambda function, but yeah, enterprise cases will connect that with a JDBC connection to database or a Postgres connection. But the concept is that it's able to talk. So that gives the connectivity from this account, which is the finance account, to the claims account. We have not made any changes in the Route 53 or transit gateway. You can see that, right? In Route transit gateway page, there is no transit gateways here. See, no transit gateways, not transit route tables, but still the traffic is established through the DNS name. DNS name given by the VPC lattice service. And these are all encrypted. The backend, you cannot see how it goes, but it all goes. But you can see the observations in the particular subnets, right? We are putting it in the app subnet. You go to app subnet and go to the route table. You can see there are two entries made here. That is the VPC lattice entry. The moment you attach this VPC to the lattice service network, you get these two things added. Now the lattice DNS name being an AWS endpoint, it knows how to resolve it on its backbone, and it knows the path it has to be within this particular range only. This is for IPv6 and this IPv4. And it will internally resolve, and then it will make a three-way handshake, start traversing the packets, and then the purpose is served. Okay, this is the way the using the manage prefix list, it was able to talk. So now we have seen this. Maybe I have another account as well, right? We have seen the diagram here. There's a third account where I have not enabled any connection with it. Let's do it in this runtime. So I'm in the first account. Maybe I will create a new share. I'll make VPC lattice share 2. I will share those particular services. Sorry, first is service network. We have to share it first. Service. Come on. Service networks. This is service network I have to choose. The service as well. Just go next. The next, grant access the principals. Who is the principal that you wanted to share? That's my third account that I kept in the incognito mode here. That's for analytics account, right? I'll try to get the account ID here. That is 6567. We would have not seen it due to that user group logo, but I have copied it. I'll put here add the principal ID. I want to add this particular account to the principal and share the resource. Now what happened? the VPC lattice is shared from this account to the another account. You go to this account, analytics account, and go to the RAM. I should be able to see my share now. I have to accept invitation and then get my share shared by me. The resources one invitation. You can see the invitation right pending. You can just click it and then okay, click on it. Accept resource share. So now you are accepting the resource from one account to this account, which is nothing but your service network, right? You have no access to the shared resources. You can see shared resources here. There should be one shared resource. That's a service network, right? Now let's go to the VPC console and go to the service networks. You can see one particular service network popping up now, right? You get the same transactions service network coming in here, and it already has one association, but that's not with this account. Let's check it. It has one association. If I see it, it is for that B45, the previous account, right? But this account has a EC2 instance here that is running on this particular VPC D61B. So let's associate this VPC with this service network so that the workloads can talk within each other. Let's go create VPC association, add it, and choose the second one, the analytics prod VPC. And again, the security group. Let's go with the default allow all now. We'll come back and tweak it. For now, I'm just giving default security group. Then just save the changes. Now, this new VPC has been added to the service network, right? So when you say it's added, then it has the routing to talk to the VPC lattice because it's in progress, right? Let's quickly go and see whether it has made a change to route tables or not. We go to the route table for that private route table. See, now there is only NAT gateway is there. There is a local connection. There is no VPC lattice connections, right? Just hold on this sheet and then go to this tab. Now wait for the other tab here. It is in create in progress, right? This should be come on a available mode. It will take maybe a couple of minutes. Once that is there, due to this VPC association, the route table will have a knowledge of VPC lattice connection, how to reach that. I will just give it a minute and then it should be popping up. So any doubt till this point, you can add it in the chat or so. So the team is very quiet. It's that everyone understood or no one understood. Let's wait for the service to be up and running. Come on. Okay. There are two. See, now you can see, right? There are two associations still in progress. Now it's you can see now it's active, right? For both VPC. And this VPC is D61B. That's our VPC D61B here. And now if I refresh it, this should have the lattice entries, the route table. And there you go. You got a route for lattice, right? Now you have three routes. You have a IPv6 route here, hexadecimal values, and you have two routes for the local link local connectivity. So now, as the VPC has the routing, maybe we can just go into this machine, connect to this instance, and let's try to ping that particular Lambda function. So I will do the curl. I'll get the domain name of that particular service here. VPC latest service, second service here. Copy the domain name. Go and do the curl here. See, wonderful, right? Now the developers can easily do miracles now. They don't need to wait for the infrastructure platform engineer saying that my VPC is there, but your guys have not done the VPC and attachment to the transit gateway. And the transit gateway routable happens once in a week or in a fixed schedule due to the sensitivity of it. So, so it's a kind of a service to service connection on the application layer itself. And now, just to give you one more emphasis on the layered security, if I try to hit on this particular DNS name, right, domain name of the first service, it will mostly fail because let me just show that it fails. Oh, fantastic! Why it's working? That could be because the IIM. I think we have relaxed it. Okay, this should not happen, but it's happening. It's a violation. But yeah, that's what happens sometimes. Good. So that gives your connectivity, right? You haven't spent much time on the transit gateway, but you are able to make a EPC lattice setup following this connection. We had a service network, we had individual services that got registered, and then there was security group as well that we attach it to the lattice group. But one more key thing, right? Now you want to secure these two resources, right? It's that these two lattice services talking to this, but we don't want this particular workloads to be exposed to some other vulnerabilities, right? What we can do, go to that particular workload. Here I have a Lambda, but a Lambda hosted on my own VPC. It's not on a AWS managed VPC, right? Here you can see the security group is fully open, right? This security group also you can change it. You can go to this security group. You can go to EC2 and then a security group here. And to this security group, in the inbound rules, you can just delete this group and add a rule where you can say be HTTP 80 from that prefix, the prefix list, right? We had it right for the VPC lattice. You can choose those prefix lists. You have it's IPv6, it's IPv4. You can choose this prefix list and lock it. So it knows that this Lambda can only be received traffic only via the VPC lattice service. So it's one more level of security, which is we are close to a zero trust network. And similarly for the instance as well, we go to the instance, there was one instance, right, where we tried that claims transaction welcome message. This one, app claims for workload 01 and security, the inbound rules. You can see here, right? I've already added the VPC lattice, the prefix list here, and then this is my own IP. So I can do the SSH to this machine, and only the VPC lattice can listen to this particular survey, or the machine is open only for the ports of this prefix list. There's nothing but our VPC lattice prefix list that you can see here. So both our Lambda and the instances are locked only to listen from VPC lattice, and the VPC lattice is connected with lattice network, service network. It gets shared now. That way, the service level network is fully enabled. The traffic goes on AWS backbone, fully encrypted TLS traffic. and the purpose is so, and this can you can scale it. You can have multiple services and different service networks. So not fully possible. And let's go back to the slide and discuss some few quick concepts. I think we're done with the demo now. Let me let's see how we can democratize this in an enterprise, right? So you always have two different teams. One is the network administrators would always want for I wanted to create a service network. I will set the access controls who can talk to other workload because there will be a network audit and the VPC association because they are not going to set the transit gateway route table, but they can definitely do VPC association. And the developers team, they can focus more on creating the services. So it's similar to the target group for load balancer. Just choose a machine, expose a port, and then register in the VPC service. And then they can do the traffic management, like an authorization. Like, for example, if there is a machine, what should be the instance role of an instance from other account that should access it? Or if we host a more ephemeral environment, a container-based environment, or Kubernetes for a specific namespace, or for a specific REST API call, a put request, a post request, you can have a different fine-grained permissions to the VPC lattice service so that you control the traffic for it. Ultimately, the vulnerability or the exposure of that particular service, depending upon criticality. And the other topic, associating the service to the service network, is something uh, which will be done mostly after an architecture review that you cannot directly create multiple services and keep adding it to service network because it has to be studied properly, approved by an architecture board. But this can be a common activity. This is the kind of a governance model that we should have it. And now, for example, if I already have a workload running on a VPC setup, how can I bring that to VPC lattice setup? Because you have seen the effort savings, right? We have not done anything on the transit gateway route table level, and we had a very good quick networking thing done, everything encrypted, the AWS backbone, the network fabric. So how we should convert it, right? It's all minimizing the network routes, right? You can create a new VPC lattice service or register the same load balancer or the same machine. So that would give you a domain name, something like this, right? App claims prod, and then a hexadecimal value. You can have a separate Route 53 private hosted zone for your domain. Like if you are interested in transactions or claims or based on the module you take it, create a private hosted zone, create an alias for this particular domain. Okay. So now what happens if the mesh instance tries to call this particular domain through alias record, the DNS association happens and it goes to AWS backbone for VPC lattice, not directly to the transit gateway. Because any resolution on AWS network takes higher priority, so the traffic by default goes to VPC lattice. And you don't need to give for both the machines. Like the first hand, you can do some small pilot projects, take one of the network and then maybe send that traffic to the lattice and see if all your conditions are met. And I'm sure it will be met because it's running on the AWS backbone. There is no much hops needed, and then it should be a encrypted one, all the security controls in place. So this way you can slightly come from the EPC to EPC lattice, provided if you can skip the transit gateway part. But still, this route is needed. For example, if you want to reach the on-premises connection for Active Directory, connect to some other key items as per the compliance, that can still be there. But the connection from one VPC to another very securely environment that you can route via VPC lattice, right? And final part, pricing. So all looks good until you come the get the bill, right? Now let's compare uh, between the transit gateway and VPC lattice. I didn't took VPC pairing. That's a very classic case for a newbie learning cloud. But the moment you come into a company or enterprise, you will have a bunch of VPC so directly bring in the transit gateway. And transit gateways are charged per attachment. It's not based on service, it's per attachment. So you attach three VPCs to it, then you have to pay a fixed amount to it. sorry, and then the data that has been processed through that attachment, and it is based on the data volume, like 2 cents per GB, like zero point 0.2 cents per GB. That's a quantification they made. But in case of VPC lattice, it depends on the number of services that you provision. So if you have 10 different services, then each service will cost like 0.025 cents, $0.05 per service. And they have a little bit data processing charge as well. And then it means the number of requests, how much you make, because it's a kind of a load balancer, right? It's an application layer proxy, which AWS fancily calls it application layer networking. So we have to play with the economics of these two. What is the current traffic ranges? What is the data transfer cost? What is the number of requests it made? So there's a load balancer from that. So you can make a cost calculation and then choose the best one that needed. You have to consider that you can associate service networks VPC, which is free of cost. If you have 100 VPCs, you can do that free of cost. But in Transit Gateway, every attachment comes with a cost. And there's a secret recipe here, like VPC lattice is charged per service. But if you can have a one DNS name and you have a path-based routing as well, if you can put multiple services in a path-based manner, then you will still be paying only for one service, which is cost saving, right? That option is there. Just need to play with the current state setup of your application and then the economics of it. I think that brings us to the end of the session. I think on time as well now. So the key takeaways of this session, I would emphasize that many times here as well. It's an application layer networking service. There is no need to go and play with the layer 4 on the transit gateway level. AWS takes care on behalf of you. And as soon as you expose your workloads to data service, you get a nice DNS name. You can convert it to a comparable one if you have a private hosted zone. And you can map all these services into a big service network as per the requirements. And then you can share it with your other accounts through RAM that we saw a live demo. And then there's also a misconception that VPC is only for microservices. It's not the case always. It has been projected in that way. You have a ECS cluster, EKS Fargate, ECS Fargate, or a EKS cluster. Then VPC lattice can also act as an ingress controller, but it has other benefits as well that we just saw now. Even for a small EC2 server or a Lambda function, if you want to have a zero trust network architecture, and you don't want to consider your IPs as an identity framework, you want to use a real identity and have multiple whitelisted security groups before accessing that particular very sensitive functions. You can use the VPC lattice. And also, there's a misconception that we can always compare with service mesh. There's AWS App Mesh service, and there are other AWS service as well. That's equivalent of service mesh. VPC lattice is a kind of a superset. It can perform the role of a service mesh. They have all the control plane, data plane, but service mesh in function, it cannot fully manage the network routing part of it. So it knows the route, so it can track it with Istio or any other traditional service mesh. But VPC lattice is a kind of a superset of it. It can also put the route table entries, all we saw in the prefix list. It's not possible with the service mesh. So this is extra outer service mesh. But having said that, right, it's all pure networking. So everything is just based on IPs and ports, which is managed by AWS through the prefix list. The end of the day, it's a kind of a private link. AWS manages it under the hood and calls it an application proxy, and hence the name application layer networking service. I think I should be good for the day. Any questions, sessions? Floor is open.
Hmm. Sorry, I don't see any questions in the chat. Like, I think it's like we extended it a pretty bit, so that's understandable. But yeah, if you want to conclude something, then you can go ahead and we can end the session.
And yeah, it's a lot of information to immediately chew through. Maybe kindly go through it and then This is my LinkedIn page. You can always connect, and then any questions on them, I can just directly ping me. I'll be happy to help you.
Yes. Thank you, Srini, for joining us today. That's an wonderful session on VPC Lattice. I feel that some of our audience may be new to this service, so they might not have that much of an understanding uh, to it. But I think they'll go through your session today, and they'll be happy to reach out to you on LinkedIn if they have something to ask. Sit there. Yeah, thank you for joining us, and I hope you have a great day.
Thank you all. Have a nice weekend.
Yeah, thank you. So, on the concluding note, yeah, thank you, Adit and Srini, for joining us today on this Build a Skills for Networking session and giving us your valuable insights on AWS networking. I hope the audience have enjoyed this session, and we hope to hear your feedback. Please feel free to say your comments on LinkedIn or in YouTube comments. We'll be happy to go through it and take it from the next session. Before closing, I just wanted to highlight on the AWS Student Community Day again. You can scan this QR, which will take you to the website. So there you can find all the details of the speakers, sessions, and there you can also get your tickets there. So what you can expect from this event is like we have a lineup of like 20 plus speakers exploring around 15 plus sessions on cloud computing fundamentals, AI. Agents, serverless, and everything and all. And these sessions will be like it's a mix of lightning talks, a 30 hour session, 30-minute session, and with a panel discussion as well. Also, along with the sessions, we are also having 4 booths. For the first time, we are doing this agentic AI job internship helper booth. So where you can bring in your resume. This particular agent will help you to optimize your resume, and it will filter out the jobs which matches your profile, and it helps to you to apply for them as well. It's very interesting, nice. If you want to explore this particular booth, please feel free to be a part of our student community day. Visit there and explore the booth. And we also have an Gen AI avatar booth, so you can create different avatars of your face there. Also, we have another booth for creating strands agent. So as you might already know that Strands is an AWS library for building agents, and we also did a deep dive on Strands in the last Builder Skill Sprint month. If you have missed that session, I would highly encourage you to go and watch that session where Vivek explained right everything from basic to like how you can build up production level agents using Strands. And also, we'll have another booth for your queries on certifications and startups. So you can visit this booth if you have any queries on certifications, like what certification I can take, or what are the resources that are available for me to use, and all those informations you can get in this booth. So I hope you guys are interested in these booths, and if you want to experience it, please visit us for the student community day. Get your tickets, and the tickets are selling soon, and we hope you to meet in the student community day. Yeah. Also, on another note, so we have done an Gen AI Builder Skill Sprint last month, as I have mentioned earlier. So the hands-on challenge is still open, and if you have missed it, so I'll highly recommend you to watch the session. You can scan this QR code, which will take you to that session, and there is this form to submit your challenge. So you can upload your solution, like either a blog or a video or even a GitHub repo, and share as a link, and share this in social media, and we'll be happy to go through it. And if your solution is really cool, we'll feature that in our handles, and you might also get a chance to win few prizes from AWS Group Madurai. So mm, yeah, that's pretty much it. Also, one more thing. There is an officially AWS agent hackathon going on. So I think this is there are like 5 days left for that hackathon. So if you are participating in this Gen AI hands-on challenge, you can also submit the same solution there as well. So you can just build once and you can submit it twice, kind of a thing. So I highly encourage you to use this for upcoming week, and explore strands and how you can build real-time agents with tools, and so it's really interesting stuff. So I hope you guys have uh, enjoyed this today's session, and I hope you to meet in another interesting session next week. So thank you for hopping in. So thank you guys.